Cloud. Awesome. Thanks, folks. Welcome to Enablement session number 1 for October 2023. Today, probably a bit of a short session, but one of the requests we had was how to run GPT with custom large projects. So for those who don't know, GPT already has a built-in, if you will, large project that it imports and then runs a certain set of tests against. You're able to use a custom version of that project if you wish, and then configure it and set up your own parameters to run your own version of the tests against that individual project. So it'll check things like issue listing, looking for specific commits, doing things with specific pipelines and MRs, etc. So it's really just a way to test, in the more generic case, a way to test individual features through more of a UI base, through more of a web base. But for a custom project, it would be a way for us to test scenarios like, hey, I have this project that's not really a larger repo necessarily, but it's got 150,000 issues or 300,000 commits. What is my performance going to look like? And what are some of the things I could do to maybe increase that performance, or what pieces of the code does engineering have to look like to maybe optimize? So we're just going to run through really quick what it takes to configure that custom project. It looks daunting at first, but quite honestly, it's not as bad as it looks. Just a lot of different options you can set, and just kind of understanding what those options do. So let me go ahead and share up a screen. We'll start with kind of walking this backwards a bit and showing you what it looks like. Why can I not find share? There it is. It's always the big green button that I look right past. I'm not sure why that happens. Cool. Okay, so hopefully you can all see this. This is on my GitLab gmgldemo.net instance that I have out there running that I use for a lot of different testing and demos. This project should look familiar to some of you. I have used the Congregate project as my large custom project. So amazingly enough, we are able to export and import the Congregate project nowadays. So that's a cool thing. And here it is sitting in this GPT, which for those of you who've used GPT before know it kind of uses this as the default spot where it loads its projects for testing. The large projects, again, kind of a GPT default. And then I've called this one GitLab CG1, Congregate 1. I believe the default is something not that. What is it? HQ1 is the one it'll use by its default. So that already is the first thing you'll see. It's a little bit different, that CG, and we'll show you where that comes in just a moment. So again, I've imported the Congregate project, 3,000 commits, 76 branches remaining, bunch of MRs, issues, etc. Not really large necessarily by the definition that is used by, I think, the other HQ, the default HQ project, but had enough data in it that we were able to do some of the configuration and such. So having said that, let's go ahead and poke on over to what that configuration looks like. So first, let's take a look at the docs, I guess. Custom large projects, I'm just looking here in Visual Studio. You can see that, right? Yes, good. Looking at it instead of looking at it on the web, so I can just kind of single interface everything for right now. Setting up custom large projects, you have to configure the project config file, configure the environment config file, and then set up the custom data itself. So that's actually relatively easy. What that means is, and again, kind of walking this backwards, the first thing you want to do is find your large project, wherever that is, and export it. You'll want that to be a tar.gz, depending on what browser you use to download it. Sometimes you'll have only a tar file. So sometimes your first step is to re-gz that tar of the export. I won't go ahead and walk through an export of a project through the GitLab UI. I'm assuming most of us know how to do that at this point in time. If you don't, just go into the project settings, advanced, and the export capability is in the settings for the project itself, and then it'll email you a link that you can click on to download the tar file, the tar.gz. Let's see. So after you've downloaded that, as you can see here, I've really just created the GitLab GPT performance. I've just cloned the repo and brought it down. So it has that default structure that you'll see in GPT, your K6 config. Under config, you have your environments, options, projects. You'll want to stick that tar.gz file underneath that projects directory. So here you see that where I've got that file located right now. And this, you'll see in a minute, is just where you'll tell GPT when it's loading the data where to find that file to import it. Because then what it's going to do is it's going to set up all its test data. It's going to import this project as the large project and stick it in that project's location we just saw on the web. Kind of now jumping to the meat of it, as far as configuring the file itself, is this GitLab cg.json. So there you see the GitLab CG. This name, as you'll remember, matches the name we saw on the web. It's just it had a 1 appended to it. That's something that the data importer will do on its own. The GPT data importer will do on its own that creates the project. But this GitLab CG is kind of the base of that. You'll see in the config here in a minute where we actually match that up too, so it knows what file to look for and what configuration to look for, et cetera, when it's running the test. So here's the file. I'm going to click back to the instructions really quick where it just kind of talks about this file a little bit. So basically all you do is you take this GitLab hq.json and you make a copy of it and you rename it to, you know, the name, whatever name you're going to pick for your custom project. And you'll see here a whole bunch of different options you can set on things. Look, like I said, it looks daunting at first, but it's really not that bad. And you just, once you kind of find an individual commit or an individual pipeline or something to use or an issue to use, you can then start to just use that one and use the SHAs that come from that one as kind of the baseline of what you do. Let's just walk through a couple of the examples really quick here. Name, fairly straightforward. Branch. So here's where we start getting into some of the meat of it. Whoa, didn't mean to do that. Sorry. Let's get rid of that. There we go. So the name of a large branch available in the project. The size of the branch should be tuned to your environment's requirements. Again, this can be pretty much anything you want. You can just pick any large branch if you're trying to test something specific about this large project. You could literally call this branch anything you wanted. Just pick any one of those, any branch in the project that exists, and kind of ignore this in favor of the other things you were trying to test specifically. Maybe that's commits or clone data, et cetera, something along that line. If I come over here to branch, you'll see I just went ahead and picked the master branch. Branch search turns to use searching branches. So this is going to go out and say, hey, how fast is a search on this project when I'm looking for a branch? Return in what, and you just give it a term to search for. I picked, you know, migra, which I figure probably shows up in some branches in the congregate project somewhere. So went ahead and went with that. Commit SHA. SHA reference large commit available in the project. The size of the commit should be tuned to your environment's requirements. So I did this. Size of the commit is kind of a slightly ambiguous thing to talk about. I went ahead and did it by the number of files and commits. So it was kind of taking what I thought of as the two different metrics for size on a commit, how many different files, how many different changes, how many different commits overall. And that's the SHA I picked. So there was a little bit of hunt and peck involved with that, you know, just going through the commits and kind of looking at what they were comprised of and then deciding which one I wanted to pick. So I picked this 3.5 BA1 here, right, that I used for that. Commit SHA signed commit. Again, a little bit of hunt and peck. And I think really that's kind of the gist of this entire thing. Again, it's not difficult if you read these to figure out that these are, oh, this is what it means. This is what it means. It's really just a matter of finding one that then suits the needs of whatever it is you're trying to test. Fairly self-explanatory blame path, raw path. Down here, we're going to skip down a bit. You get in here and do MR commits ID. So this is the IID of a merge request available in the project. Now, the reason we pick the IID, of course, is because when you import it, the ID of it's going to change, but the IID in reference to its location in the project is going to stay the same, that internal ID. So you're going to want to pick those when you do the data entry here. And again, that's actually fairly easy because you're always going to see that. It's always going to show that in the UI anyway. You're never going to see this is the 1 millionth merge request or commit on this instance. You're always going to see that ID anyway in terms of what it is in relation to your project. So just pick those IDs when you inject those in here. Let's see, I'm trying to think of some of the ones that were maybe a little tricky. Pull data, push data, pipeline. Let's see, what's some of the other ones? Blame, raw, rendered, source. pipelines, commits. Yeah, let's look at git pull data and push data. Push data used for git push test. No need to change the reason. Git test a custom project. You have to please refer to this documentation. So this documentation will give you a little bit of information about what it's trying to do and how, well, really more to the point about how it's doing it. This push test, I just generally picked anything that was pretty basic since I was just trying to get something that works. So I just picked a branch that existed. I picked whatever the new head SHA should be, the current head SHA, and injected those in here. So, and it tells you pretty much exactly what you're supposed to be looking for. The head commit of the branch of the branch currently. And then you just pick any commit older than that on the same branch. And then it'll run the test based on that information. So again, I guess what I'm trying to stress about this is when I first looked at it, I went, holy crud, this is a ton of information. This is taking me weeks to figure out. It took me about half an hour. So it's not really nearly as bad as it looks. And it's fairly self-explanatory. The documentation on it is really good. So again, let's assume we filled out all this information. These counts are fairly easy to get. Issue count. These are the totals. These are not just opens or actives. These are total pipelines, total issues, total merge requests on a project that it currently exists. Figure those all out, fill those all out. And then you've got this CQ file. I'll be perfectly honest, I left, I think, all of this alone. I don't think I changed any of the search terms for the sake of this demo at all. Let me run up here into environments really quick and show you the custom environment configuration. So let's say you've got your download, you've got your JSON file set up, you've got the name set. You see here again, GitLab CG in that file. Let's go here to the custom actual configuration for the environment. I just used the 3K baseline for the sake of the demo. So it's got, still the 1,000 project subgroups, 10 projects per subgroup, et cetera. I probably should have tuned these down a bit, but changed the URL, of course, to point to my instance, the root user. I didn't change any of this because I'm only using single storage nodes and everything on my instance right now anyway. Here's the part where we start talking about that custom large project. And the only thing you really have to change is this right here. So as you see, I've got that GitLab CG here as well. Again, matches the name of the JSON file. It matches the name. And that's what it's going to use to create that name in the web when it imports it, etc. And that's really it as far as the configuration of it goes. Did anyone want to dive into any of the configuration pieces specifically really quick, or documentation sufficient?
So when you were building out the config file, you mentioned you kind of start with a baseline template of like GitLab HQ, tweaked it for congregate. But you said it took you about 30 minutes to kind of figure out some of the more complex ones. So from start to finish, did it take you about a half hour to like build out this file, and then you're just off to the races with running a test?
I think start to finish once I got into it, like 30, 45 minutes. It didn't take as long as I thought it was going to.
Cool.
It like the first and really like the first couple where I was like, what are you asking me for? What are you asking me for? It took a while. Then I got into the rhythm of, oh, I understand what you're doing. And I kind of started reusing information across them. It's like, oh, I know this now.
Okay, cool. Yeah, because I feel like this does look kind of daunting without like having done it before. But I figure if the docs are solid enough, that makes sense.
Yeah. To get through it, file source path, file rendered path. Okay, cool. I went ahead and just put like the run commands and stuff like that in the notes for today's session. Again, I'm using Podman right now because I was helping some folks with Podman stuff yesterday. So that our Podman Docker would be exactly the same. You'd replace Podman run with Docker run. I think I put Podman in there, or did I put Docker in the notes? I can't remember. Oh, I put Docker in. Okay, cool. I'll skip running this in real time because it's going to take a minute, but I will show you the output of those tests just so you can see what they look like. Oh, excuse me, some results. So because I have run this multiple times, of course, while testing it. So again, pretty standard test results as far as a GPT run. It doesn't really change a lot as far as the structure of the JSON files you get and everything like that. The piece you're going to want to look at is, let's see, if you run here, if you look at this, so this is like the output log for the entire test run. Let's go ahead and check for CongKit, or what is it? No. GitLab CG. Am I looking in the wrong file?
Was this where the Congra came in? The way that you had named it?
Maybe, or I might just be looking in the wrong results file. This is from yesterday, right? Yeah. Searching for something weird, because that should definitely be in there. I'm like, this is the test I ran yesterday, right? That should definitely be in there. I'm a little befuddled right now. Sorry. Oh, did it skip web results or something on this one?
I was gonna see us.
Oh, it did. Yeah, there. First, I must have stopped that one halfway or something because it skipped web results. There we go. So let's use this one instead. Apologies, I must have killed that one halfway through doing something else. There we go. Right. So here you see one of the places where it's actually using that custom large project then. This is the one for the commits. So if you check the endpoint URL, you'll see it's using that GPT large projects GitLab CG1 commit, and then it's looking for that big long commit. Again, that big long commit points to this commit SHA here. In this particular test, it's using this one. If you want to determine what is being done in any individual tests, it's really easy to do. It tells you, here's the script I'm running, web project commit.js. You go up here into the actual tests themselves. You can pop into that web project commit. If I can then understand how alphabetical order works, there we go. And it tells you, kind of parse through the JScript here and you can see what it's trying to get. Endpoint path is the environment plus that plus the commit/commit SHA. So that's the one it's trying to pull out of there. And if you look over here, commit SHA, that's the data it's trying to use. So that's the one it's looking for. And again, it'll just try to go to, if I click on that, the test is literally in this case, open this, see how long it takes to open that commit. And that's the metric it's testing against in this particular instance. Same for I think web project files. There we go. Yeah. It's format JSON. Let's see, is it file or files? Let's see, let's do file blame instead. Blame's a good one, I think. Right. So you pop that one open, maybe. Come on. There we go. Hear that I just opened it 6 times. There it is, just looking at the blame file for main.py in the congregate. And again, you come over here, file blame path, congregate main.py. So that's the file it's using for that individual test against that large project. And again, this is just a raw, how long does it take to open that page metric? So this is testing the instance and the render path for that. And in a nutshell, that's really all it takes to do a custom large project. Again, looked daunting at first, turned out it wasn't quite as bad. And you can reuse a lot of this information anyways. You see my commit SHA is my same as my clone. I figured if you're finding one that's the big one you're going to use for something, you might as well use it for everything else too, to test that full measure of functionality with pull, push, large commit reads, opening up the UI page, etc. So you do end up reusing a lot of that same information if you want. Comments, questions, concerns, weekend plans, hit me.
I'm just trying to think of like how we would apply it for like customers that have massive repos, and like I assume we do like, because we can limit this to just run against that, like a copy of a large repository, right? So like trying to think of if it's a customer has 100 large repos, do we try to give baseline from the source, or if it's unstable enough, we just don't mess with it and just kind of see what it looks like as an improvement. Like this is cool. I'm just trying to like picture in my head kind of the workflow of we've set up GitLab, we've run stock GPT, now let's run it against some large projects that we're migrating. What does that workflow look like?
So you could certainly do it in such a way that you changed this and this and this and your config file and such to point at something pre-existing. Is that what you're kind of getting at? Like instead of running it against their instant, we can run it against an existing system.
Mm-hmm.
Yeah, because one of the first things it'll do when it generates the data is to look to see if this project already exists. So if you tune, all the different names, and then you go into this config and set the root group and set these things up in such a way that it then knows where to go, and it goes, oh, this project already exists, it should then use this configuration file, however you've set it up, against that already pre-existing project.
Okay. Yeah, because I'm thinking like there'd be if there's customers moving off of like it's a smaller self-managed instance moving to something that's a little bit more stout, I have to wonder if they want to see the metrics of like, okay, it takes 10 seconds to load this file on the old instance, it takes 1 second to load on the new instance. I'm just thinking of like what when you provide some more tangible data. Granted, I assume if once we run GPT and show like, yep, it's working as expected with a 5K reference architecture. Thinking through like a picky customer that needs more proof that stuff works. But okay, this is cool. I have not gone this granular with GPT before, so this is definitely interesting to see how it's all set up. And yeah, the amount of SHAs in that JSON file is definitely daunting at first. I'll have to play with this more.
Indeed, yeah.
And then
Go ahead.
So I have a customer that Joe is on a stability problem for, and we're starting with a baseline with GPT. And one of the situations, or one of the challenges that they have in their infinite wisdom, is all they have is prod, right? So they have no qual, no test, no geo to run against or whatever. And so it's a double whammy. First is there's no real good time to ever really run GPT except in the middle of the night. And then secondly, after we're done, when I started 2 years ago, there wasn't any way to extract the data, and we really only recommended using GPT to worry about what that looked like, right? So I'm curious about, has that changed? Because I heard Joe mention something about, there was a way, I guess now in Congregate, to extract, or excuse me, out of GPT to extract some of that data. And that was something that I hadn't heard, and was curious if that, how real is that, or what does that actually look like when we try to take the test data back out now?
So we kind of lost you for a second there during your speech. So I'm
sorry.
No worries. So let me.
Yeah, my bad. Yeah, the question was a couple of years ago we couldn't actually extract test data out of GPT, right, out of the instance, and so I'm curious, can we do that better, or what does that look like today when we have a client that doesn't have any sort of test environment?
So what do you mean by extract test data? Like,
well, so we insert it, right? So with GPT creates all of this test data. If it's in a production only environment like this client happens to be, how clean is it when we try to take that out, or is it just there forever?
So there is cleanup after testing that you can perform that GPT has built in. I be perfectly honest, I've never run it,
Okay.
but it does exist. I don't know how long ago or how long it's existed for, but it is there. So
Okay.
GPT tends to put things in one spot anyway. If you look at this config, we have many groups and projects, and then the subgroup prefix and everything, and then your root group is GPT for your data. In general,
Yeah, we should just be able to call to those things. Yeah, right.
You should be able just to blow away that one root group, and it should take care of the rest of the world for you. But
okay.
Again, it does have its own cleanup base, and it basically just runs its data importer based on this configuration backwards. It just goes delete and insert. So
nice. Yeah, I guess it did, if I recall, Michael, and you might be able to comment. I remember it didn't used to be that way, about 2 years ago. So
Yeah,
somebody probably said, "Hey, customer only has prod."
yeah.
Anything else? We're happy to give y'all back some time. I gotta go prep for like 6 interviews.
I'm good. This is a really cool demo. Thanks for putting it together, Glenn.
No worries. Always looking for more folks to do demos. Hint, hint. So jump on that.
Do you do the same one like in 5 hours, or how did you
Yeah, I'll do the
that
same one again, basically.
okay.
Slightly
Okay.
different.
Yeah.
Probably just because I don't have a script. I pick it up as I go.
Yeah. Thanks for this one.
Yeah, no worries. I think the one thing I do want to test that we talked about is a lot of the existing project theory around that. I'm going to go test that right now and see what happens. So,
and doesn't GPT come with that with the GitLab repo by default when you like populate it, when you use it to populate the instance with data?
I don't know what project it's uses by default.
Because I think last time I used GPT like for a health check, it creates under that GPT folder a bunch of smaller ones, but it does put the GitLab project in because of its MR issue, whatever complexity.
If it does, it puts in a trimmed down version of it. I mean, I can't.
Mm-hmm.
I mean, 6,000 issue counts seems a little short for the GitLab project. So I don't know what version of it actually uses. That's good. It's a good call.
Yeah, because you put in the congregate ID and so to use that one. Yeah.
Mm.
Yeah.
Awesome. Now, let me go ahead and turn on sharing real quick. Maybe. No, apparently not. There we go. And whatever else.
Loading forever to the cloud.
All right. Thank you, Glenn. Have a great weekend.
Yeah, no, Trey. No problem. Thanks, folks. Appreciate it. Take it easy. Have a great weekend, all.
Yep. Bye-bye.
Yeah.
Have a good one.
Bye.
Bye.